Alright, so in part one and two, I went through and I discussed how to make scatter plots and how to interpret a lot of the data that you can actually get from creating a scatter plot to analyze the relationship between two variables. And I wanted to talk a little bit more about some key points here. So in class we discussed how an R value, which remember is the correlation coefficient, is only going to range from -1 to +1, and it strictly measures the strength of a linear relationship. So let me see if I could find where we mentioned that here. Yes, so the correlation R measures the strength of the linear relationship between two quantitative variables. So make sure we note that it's not going to measure how close the coordinates lie in a U-shape, it's going to measure how close they lie in a line. So an R value is not going to measure curved relationships. Some other key points about an R value, I'm just kind of clicking to where I find my place, which I think is here. Yes. So an R value is going to, or that strength, the value for strength is still going to be the same number even if you switch the X and Y. So if you accidentally put the explanatory in the L2 and the response variable in your L1, so if we were to switch these around, it's still going to be measuring the strength to that line, so it's going to stay the same. But what will change is your slope and y-intercept. So that's why it's important that you keep your L1 and your L2 corresponding to your explanatory and your response variable, because if you flip it, yeah, your R value won't be wrong, but your slope will, your y-intercept will. If you do any type of predictions using your line of best fit or finding residuals, those will be off as well. So definitely make sure you get your explanatory and response squared away, but the R value will not be affected if you accidentally switch the variables around. The R value does not have any units. Notice on this scale, it's just going from -1 to +1, so like I said, it's not going to be measured in inches or in feet. It's just a value, a number, a decimal, 9 times out of 10, because it's very hard to have an R value of exactly 1 or -1 of perfect strength, perfect linear strength. Let's see, anything else I wanted to mention here? An R value would be definitely affected by outliers. So I'm just going to pull something else up to talk about that. So remember that an outlier is something that lies far out. You can almost think about it as like far to the left or far to the right. So an outlier would be very far from the rest of the data, not in line with the data. A point that's in line but kind of far away from the group, that's called a high leverage point. It would still be in line with the data, so it wouldn't necessarily, fall out of the, or away from the line of best fit, or the least square regression line. It'll still be close to it. But the thing is, it has an X value that's pretty far from the rest of the X values. So it won't really affect an R value, your correlation coefficient. So a high leverage point really won't affect the correlation coefficient because it's not going to shift the line since it's kind of in line. But if you think about an outlier will affect the least square regression line, because that line of best fit is trying to be as close to all these points at one time, and the minute you include an outlier, it's going to shift that line to be somewhere in this blank space because it wants to be close to that point as well. So it would actually have an effect on the R value, it would have an effect on the slope, and it would have an effect on the y-intercept. So that is what an outlier does. To be an influential point, it is going to be considered to have a greater X value and and not necessarily an abnormal Y value. So notice here, influential point could be outside of the X range because it is considered a high leverage point. So it could be outside the X range in a low manner, or it could be outside the X range in a high manner because it is considered a high leverage point. Yes, it's an outlier because it's far away from the rest of the group. So it's an influential point because it will impact the least square regression line. But basically an influential point will be any point that impacts that slope and that y-intercept. It will impact the slope and y-intercept. Whereas notice that an outlier, it doesn't necessarily have to be high leverage, meaning it doesn't have to lie far outside of the x values. Because notice this point here, it has an x value similar to the rest of the x values. It's right around the minimum, actually, of the x values. So it's not outside of the x range. But an influential point, it could be outside that x range. And as long as it influences the slope and the y-intercept, so it impacts that least square regression line, it is considered influential because it's changing the slope and y-intercept greatly. Alright, obviously, like I said, an outlier does too. It does change it, but it doesn't necessarily have to be outside of the range of the x's. Whereas that high leverage point, it would stay in line, so it really wouldn't affect the r value, the slope, and the y-intercept. But it's kind of like extrapolation if you think of it in a sense. Remember I discussed extrapolation, I think in part 2, where an x value is being measured, or the line of best fit is being used to predict an x value that's far away from the rest of the x values. So yeah, that point right there is not so great. You know, it's not so great to use data around this x value, or data values around this x value, to predict any of the y values because it's so far away from the rest of the x values. Alright, and I just have a little sticky note here to make sure I discuss any little things that I wanted to mention. So R is only for linear strength. To measure linear strength, it has no units. Oh, I want to talk about this one really quick, but I did discuss how the r value, the slope, and y-intercept would be affected. Alright, so I want to mention this last little bullet here. I wanted to go back to my graph really quick, and I'm going to go get that r value. Remember, I go to number 8. I'm going to change this back. I had it changed in the part 2 video to resid. Alright, now I'm going to calculate. Alright, so I just wanted to mention here, remember the r value is called the correlation coefficient. The r squared is your coefficient of determination. So remember that your coefficient of determination tells you how much variation in the y value can be explained by the x value. So if you have, I just want you to notice, if you have one, you have the other. Let's say, for instance, a problem gave you an r value, and it told you to find the variation that could be explained by the other variable. Well, you would just need to square it, because r squared is r squared. So if you have r, you can find r squared. And vice versa. If they told you that 95% of the variation in bear's weight can be explained by their neck girth, find the correlation coefficient. Well, you know that the percentage of variation in one variable that explains the other is the r squared. So if they're giving you that 95%, you could just take the square root and you'll have the r. You'll have the correlation coefficient. Alright, so don't think, if they give you one, oh, how do I find the other without the data? You don't need the data. If they give you one, you have the other. Alright, that's the only other thing I wanted to mention. Hopefully that sums up the unit for you with all 3 parts of this video.